We've looked more closely at syn additions. Now let's look more closely at anti-additions, specifically anti-additions with acyclic alkenes. Now to start this conversation, we are going to go to a cyclic alkene. Cyclohexene, super simple compound. We will take this and treat this with Br2. This could be Cl2. This could be any of these dihalogenation conditions because they are all anti-additions. And you might be tempted just to simply say, oh yeah, this does a dibromination. And it gives that product. Well, that is not a very specific answer. We need to actually show the relative orientation. We've created two new stereocenters here, and we want to make sure that we get those drawn properly. So we need to have either this product, and that's a valid answer, or you need to show this product. Again, with the bromines anti, the relationship between these two compounds, these are enantiomers, and they actually both arise from the same intermediate. If we were to do this addition, this starts with the bromonium ion, and the Br minus, when it opens up this bromonium ion, it can either attack from the bottom or from the top. Okay, both those reactions aren't occurring at the same time. We can do either or. If we attack this bottom method, we're going to get this compound. If we attack with this top arrow, we're going to get this compound. These are going to give us mirror image products. These are enantiomers. So we have to draw specifically the trans product. Now let's get to the point of this video, which is to look at these reactions on acyclic molecules. So if we treat this alkene with Br2, we are, you don't want to draw this as your product. Oh yeah, I know, the bromines go on different carbons, and you get an addition reaction. That is correct, you get an addition reaction, but you also create two new stereocenters, and you need to show the relative orientations of those stereocenters. So let's assume the bromine on the left carbon ends up from the top face. Well, what was the bottom face needs to be shown for the other carbon. And that means we have a hydrogen to fill out the octet for that carbon. This is an accepted product, or it's an enantiomer. So this compound plus its enantiomer are okay compounds. How would we show the enantiomer? Well, simply swap the bromine and hydrogen for the top, the first stereocenter, and then for the right stereocenter, swap the hydrogen and bromine for that stereocenter, and you will have inverted all your stereocenters, and you will draw the enantiomer. This compound would not be a correct answer. So let's draw the bromine. One bromine up, and then the other bromine up. This would only happen if both bromines attach from the top face of the molecule. So this would be the syn product. But that's crazy talk, because brominations don't go through a syn process. These are anti-additions, so we need to show the anti-product. So be careful. Anytime you start generating multiple stereocenters, you have to be very careful about which product you show, and the product has to be consistent from the starting material that you used in the reaction.